Welcome to the Explainer. When we look up at the night sky, we kind of just trust what we're seeing, right? We expect the death of a massive star to be this spectacular, universe-shaking event, like a blinding supernova that outshines entire galaxies. But nature actually has a pretty dark sense of humor. Today, we're diving into a genuinely chilling paradox. A star that is completely dead on the inside, but absolutely alive on the outside. We're talking about a star that continues to shine, fuse elements, and radiate heat, all while a silent, invisible black hole is literally gnawing at its very heart. Okay, let's contrast this spectacularly violent death we normally expect with the eerie, completely silent nature of a living grave. In a typical core collapse, the iron heart of a star collapses, bounces, and sends this massive shockwave tearing through its outer layers. It obliterates the star from the inside out and leaves behind a visible glowing corpse, like a neutron star or a black hole. But a living grave? That involves a completely silent collapse. The exterior remains entirely unchanged, hiding a newborn black hole deep inside. For a time, the star simply carries on as if nothing happened. Here's our quick roadmap for today. We're going to kick things off with the star that won't die, move into the necessary madness, and then look at three distinct case studies: the red supergiant, the Wolf-Rayet star, and the massive population 3 monster, before wrapping up with a silent fade to black. Section 1. The star that won't die. So what exactly is a living grave? Well, it's a temporary, incredibly violent, and highly paradoxical state. The star continues to shine brilliantly while concealing a feeding black hole right at its center. I really want to emphasize the word temporary here. This is not a stable setup. It is a fleeting moment where the star literally fools the rest of the universe. It radiates heat and looks perfectly normal to anyone watching, but on the inside, a singularity has totally replaced its core. Let's move to Section 2, the necessary madness. Now, for a black hole to form without sending out a shockwave that blows the star to pieces, 4 absolutely insane things have to happen perfectly in sync. First up, perfect symmetry. The collapse has to be as smooth as a glass marble. Any turbulence, any rotation-induced jets, or asymmetric bursts, that'll create a shockwave. Second, the hypercritical trap. Matter has to fall into this newborn black hole so fast, and we're talking hundreds of solar masses a year here, that the light produced by the infall gets swallowed right back into the abyss. The radiation literally cannot outrun the gravity. Third, you need a compact seed. The pre-collapse core has to already be tiny, almost the size of a neutron star, so the event horizon just appears like magic. And finally, the silence of neutrinos. Normally, neutrinos carry away all the energy of a collapse, but here they must deposit their energy so gently within the star that absolutely no expansion occurs. It's an incredible, almost impossible cosmic balancing act. All right, Section 3, the red supergiants. So this whole phenomenon actually scales with the size of the star. We're going to start on the smaller end of the giant spectrum, with red supergiants sitting somewhere between 15 and 25 times the mass of our own sun. Imagine a diffuse crimson balloon like Betelgeuse, so massive it would swallow Jupiter's entire orbit. But it's cursed. Looking at the timeline brilliantly illustrates the sheer disparity of this eerie death. In less than a single second, the inner iron core vanishes into a black hole just 6 kilometers across, completely silent. Then, for an entire month, the exterior remains completely unchanged. The star's surface just keeps up its 3,500 degrees Celsius glow. Convection cells are bubbling away. To anyone watching, it is just a normal red supergiant. But deep inside, the black hole is feeding. Because the star's envelope is loosely bound, the inner layers eventually drift inward and hit the accretion disk. That releases energy, trapping X-rays that heat up the dense envelope. Finally, maybe 6 to 12 months later, the envelope expands. The star might let out a faint red transient flash, basically a failed supernova, before the black hole consumes most of the star, leaving only a thin, expanding shell of gas. It's just a slow, quiet consumption. Section 4. The Wolf-Rayet star. Now we're escalating. These stars are the naked cores of former giants. They have almost no hydrogen envelope left at all. They're far more massive, ranging from 25 to 40 solar masses, and blazing hot with surface temperatures well over 100,000 degrees Celsius. Because they're smaller in radius, but way heavier, their demise is going to be drastically faster and much brighter. Notice just how rapid this is. At 0 hours, the iron core collapses silently. For just 1 single hour, the exterior remains completely unchanged. The intense stellar wind keeps blowing, the spectrum looks totally normal, but beneath the surface, a black hole is frantically feeding on carbon and oxygen. Now, because this specific star has a very thin envelope, the accretion energy escapes incredibly fast. Within just days, X-rays pierce the star's surface, making the whole photosphere boil. Between 1 to 4 weeks later, the star doesn't go supernova. Instead, it turns into an ultra-luminous X-ray source. The black hole accretes so violently it outshines 1 million suns in X-rays, blowing off the outer layers until all that's left is a naked black hole. It's a very brief, incredibly bright flash where the exterior changed in mere hours. Section 5. The Population 3 Monster.
We are stepping back into the early universe now. These ancient monsters are first-generation stars made of pure hydrogen and helium. And they are almost unfathomably huge, boasting 100 to 500 solar masses. They're so massive that their cores are actually supported more by radiation pressure than gas pressure. And this immense scale makes their living grave phase the absolute longest and strangest of all.
This timeline is literally mind-bending. At year 0, the star reaches a temperature where photons actually convert into electron-positron pairs. That triggers a sudden, catastrophic collapse inward, but look at what happens next. For 1 full year, the exterior remains completely unchanged. Why? Well, because a 300 solar mass star has a radius larger than Earth's entire orbit. Information from the collapsing core travels outward at the speed of sound, which is basically glacial compared to the sheer massive scale of the star. Meanwhile, matter is falling into the black hole at over 1,000 solar masses per year. The radiation is so trapped it just flows right into the black hole. Finally, between 1 and 3 years later, the gravity completely dominates. The star's envelope, still shining brightly, simply begins to drain inward like water circling a drain. The surface cools, shifts red, and then it just vanishes silently into darkness, leaving a massive black hole behind. No explosion, just gone. Section 6. A silent fade to black. Bringing this all together, we can really see the whole picture. We've got our red supergiant sitting at 15 to 25 masses, silently hiding its death for months before turning into a faint red transient. We have the Wolf-Rayet star at 25 to 40 masses, hiding its black hole for just hours before erupting as this massive X-ray source. And we have the POP3 monster, 100 to 500 masses, keeping its secret for years before simply vanishing. Contrast all of that with a normal massive star at the bottom, which rarely forms a black hole silently, and usually explodes as a massive supernova in mere seconds. You can clearly see how the mass and the envelope size totally dictate the lifespan of a living grave. So this all leads us to the ultimate question, doesn't it? Could any star maintain a black hole at its core indefinitely? Could there be a permanent living grave out there, acting as an eternal heart of darkness? Well, the short answer is no, absolutely not. Real astrophysics strictly forbids a permanent living grave. Think about it. A normal star is an engine of fusion, but a black hole is an engine of gravity. They simply cannot coexist in equilibrium. First, there's pressure. The black hole provides zero outward force, meaning the layers above it absolutely must fall inward. Second, temperature. The black hole's accretion disk is hotter than any fusion core. We're talking hundreds of billions of degrees. That immense heat inevitably leaks out, inflating and violently ejecting the star's envelope. And finally, time. Even in the absolute best-case scenario with a massive, low-metallicity star, the free fall time of the star's envelope is finite. Eventually, gravity always wins. The living grave is strictly a transient wonder. It is a star that has already died but just hasn't told its outer layers the news yet. I want to leave you with this really haunting final thought from our source material today. The living grave violates our basic intuition of how the universe works. We expect death on a cosmic scale to be dramatic, right? A flash, a massive bang. But nature also allows this quieter, far more unsettling death. A star whose heart collapses into absolute darkness while its face still shines. For months, perhaps even years, it fools the universe. When the exterior finally changes, it does not scream, it simply stops. And somewhere in the dark between galaxies, a black hole drifts, carrying the ghost of the star it once wore as a mask. Thank you so much for joining me for this Explainer series. Keep wondering, keep looking up, and I'll catch you next time.